Okay, start to finish. Video is off because I'm on a Zoom call, which no students have joined yet. So I'm going to see if I can do this before anybody comes in. This is the one IXL dealing with triangle congruence by side, 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 angle, side. So we're going to see if we can apply some of these things. Let's take a look here. Y is the midpoint of Vx and UW. So there's our given. I could highlight the given right there. And we're going to complete the proof about the triangles being congruent. So let's see, Y is the midpoint of Vx. So this side, Yx and Vx are congruent. That's what this statement, Yx and, oh, Vy, I'm sorry. That's this one here, definition of midpoint, definition of midpoint. I got two sides are congruent. They're giving me this other side, so that means that I've got what looks like side, 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 because that's all we've talked about in this proof are sides. So I'll submit that and be correct, and let's move forward. My internet is slow, so it's thinking about it. Come on, submit. Okay. Wow, I've got a side here and a side here, and I've got another side there and another side there. So if I had VS and UT, I'd have side, side, side. But I don't. They're telling me about angle SWV. That's this angle right here. And that angle is congruent to this. Those are vertical angles. That's why they call it the vertical angle theorem. And you can see that we have side, angle, side for the reason that these two triangles are congruent. So let's move on. Wow, I'm already at a 36. Probably don't even have to answer very many questions. Let's see here. Given Q is the midpoint of PR. So that would mean RQ and PQ are the same. And that's this right here. Definition of a midpoint. It's also giving me RT and QS. That's a side. And it's giving me PS and QT. Gosh, they give me side, side, side. So they've given me only three sides. Haven't talked about anything else. Terrific. I'm at a 50. Let's see here. All I see are a bunch of sides. I see WU as a shared side. That's the reflexive property right there. UW is congruent to UW. There's that reflexive property. They've given me a side. They give me WX and WX and UV are congruent. And VW and UX are congruent. So I've got a side UV and XW. I got a side and I got another shared side. That's side, side, side. Just a bunch of sides. I'm at a 60. Let's see here. Ooh, now I got to come up with more than one reason, so they do get a little more challenging. I do see a shared side, TV and TV. Oh, look at that. There it is right there, TV and TV. That's the reflexive property of congruence. I don't know what the reflexive property of equality is. It didn't say equal. It says congruent right there, so we're going to use congruence. Let's see here. Angle TVW is this one, is congruent to angle UTV. They're telling me these two angles are congruent. Oh, but they're parallel lines. I see. And so this angle right here and this angle right here are alternate interior angles. And so that's the alternate interior angles theorem. We'll learn more about that in module 19. Let's take a look. Triangle. So let's see. I've got a side and then an angle there and an angle there. That's alternate interior angles. And then I got the shared side. So I have side, angle, side to prove that these triangles are congruent. Alternate interior angles theorem, that might throw you off a little bit because we haven't seen that yet, but that's okay. We'll learn about that next week. Let's see here. VY bisects angle WVX. That means if this is the bisector, then this half and this half are the same. So these two angles are congruent by definition of an angle bisector. So let's see, WVY. That's this one here, and XVY. So that's going to be the definition of an angle bisector. And I got a couple of givens. VW is congruent to VX, so there's a side. I have a shared side here. VY is congruent to itself. That's the reflexive property of congruence. And let's see, I have a side, an angle, and then a shared side. And then I have a side, angle, and a shared side. So that's side, angle, side. Oh, they even gave it to me already. So I went from 68, now I'm at a 76. Oh my gosh. Now I've got triangle PQS is equilateral. Definition of an equilateral triangle is that all the sides are the same. So PQ, PS, and SQ are all the same. And right here, if I see PS congruent to QS, that's probably going to come from the definition of an equilateral triangle right there. And if I have this side congruent to this side, do I have SR? What else do I have given to me? PT is congruent to Q. Ooh, there's a leg. PT and QR are legs. Those are equal. Oh, RQS, I have an angle. RQS is that angle right there. SPT is that angle right there. So I have a side, an angle, and then another side. So you can see here, there's a side, there's an angle, and there's a side. Step 2 and 4 were sides. 3 was an angle. This is side, angle, side. I'm at 82. H is the midpoint of GI. Well, if H is the midpoint of GI, somewhere in here is going to be the definition of a midpoint. IH and GH, probably. GH, HI, that's the definition of a midpoint. Let's go find it. Definition of a midpoint. Let's see. H is the midpoint of GI. Well, reason. That's a given. So let's go find given. And then it says GJ is congruent to IK. Gosh, that's another given. And GJ, IK. So this side is congruent to this side. I know this side is congruent to this side. And look at this. They're going to give me another side. HJ is congruent to HK. Well, that's also a given. So they gave me 3 sides, and I'm going to have side, side, side when I'm done. Right there. Side, side, side. What am I at, 86? I think I'll stop right there. If you guys want to keep going, you can. Not too bad a deal.